Hey guys, in this video I installed a KDSS spacer to the front of my 2019 GX460. I want to give a quick shout out to Tinker's Adventures. It's a great YouTube channel and he has a really in-depth video on KDSS. There's a link in the description. I recommend watching that video before this one. It'll probably make more sense. And he's got some really good visuals with lasers up on a lift showing the interaction between the KDSS sway bar and the control arms during cross-axle flex. What this spacer does is it makes the fixed link, aka the passenger link of the KDSS system, about an inch and a half longer. Um, in my mind, and a lot of people's minds, this is a good mod once you lift the vehicle. Um, I'm certainly convinced that it helps keep the KDSS sway bar flatter and would improve on-road performance. But I really wasn't sure how it was going to interact with the suspension off-road in a full flex scenario. So what I did was I took some corner travel index flex measurements before and after installing the front KDSS drop spacer. And what I found was pretty surprising. So bottom line up front, I find that on the front of my truck, I lost a significant amount of travel in the scenario where the front passenger tire is up. I'm going to install it and we're going to see how this changes the suspension droop and flex of the vehicle. I'm just doing the front one. And yeah, so we're going to start off by establishing our initial conditions. This is the height from the mark on the fender to the top of the rim. Did that all the way around. Now I'm going to jack the truck up and get all four tires just barely off the ground, and I'm going to measure that distance at full down travel. After that, we're going to put it on the flex ramps and flex it out on the corner travel index ramps, both sides, and that will establish our initial conditions. Then I'll install the spacer, repeat all those measurements, and see if anything changes. And that'll tell us if this spacer is a worthwhile mod. You can also see that the KDSS cylinders dropped all the way down, and I'm using almost all of my available space. That's why that skid plate has to drop down so far, is for this type of flex scenario right here. Looks pretty mean though. All right, so I unbolted the factory KDSS bolts, these guys. And now you got to put these big bolts in with this spacer in between. I went ahead and undid my lock ring and moved it out of the way, and that made it pretty easy to get to this point. Now I've got to get the arm pressed back up and I can start trying to line it up. Definitely be careful when you're putting these bolts through the spacer and the bottom clamp that you don't end up cross-threading these holes up here. I'm sure that is a thing people do all the time because you're working with some weird angles and some weird geometry here. All right, so what I'm doing was I put a jack stand underneath the arm, let the weight of the truck down a little bit, and you can see that that pushed it right up in there very nicely. And I just checked the alignment with the holes. Everything feels good. So I'm going to attempt to put my bottom clamp back on. Really not a bad job so far. Should be ready to do another flex test and see if we made any improvements. Significant meaning like 38%. I had a very small gain in the opposite flex scenario, about 2%, which is probably in the noise of my measurements, definitely is, with the driver's front tire up, and a small improvement at full droop on the passenger side, with about 8%. So I don't think you should do this mod, and I'm going to make another manufacturer mad by actually testing their products and putting numbers out there. Before you disagree with me, please be ready to have some numbers to share, because everyone does these mods and no one does any testing. And then people like me go spend $70 plus shipping to try out this mod and find out for ourselves it's a terrible mod for people who actually off-road. If you just daily drive this thing and you want to lift it and you don't really go to max flex, it's probably a good mod for you. But if you do any kind of off-roading, nearly a 40% loss in one of your cross-axle scenarios is unacceptable. So I'm going to try to walk through the numbers here and show you exactly what I measured and calculated. And then I'm going to try to go over to a whiteboard and show you why I think I lost so much flex. So first of all, I always start out with the truck on flat ground, and I measure from a mark on the fender to the top of my wheel. And I use a straight edge with a level and a tape measure to do this to try to control the air as much as possible. And these were my full droop numbers. So this is with the flat is with the truck sitting on the ground. Full droop is with the truck jacked up and the tires an inch off the ground. So that gives you your down travel numbers right there. That's pretty straightforward. I just do that to establish a baseline. Then I put it on my corner travel index ramps to flex it out. Flat is the same numbers from up here, as you can see, all the way down. Flex is the number from the fender to the top of the wheel once it's flexed out. F driver up means front driver's wheel is up, and conversely, I didn't put it in here, but the passenger rear tire is up. So these numbers make sense, right? When your front driver's up, this number is small, and your front passenger number is big, okay? So then from all these numbers, you can take the delta, very simply, take the absolute value of that, and that tells you how much change you had when you're on the ramps. Front flex total is just adding up the change in both of your front wheels, okay? And total flex is adding up the change in all your wheels. So to show you the formula, it's pretty simple if anyone wants to fact check me. So this is what I got at the beginning of the day before I did the mod. Pretty decent flex. It's about in line with what I had stock. And the reason it's not better than stock is because I'm running heavier spring rates and more preload. So I don't hit the bump stops anymore in a cross axle scenario. I basically traded some flex for extra ride height. And that's what happens with these types of suspension systems. And that's okay. I needed the ride height. And these numbers are pretty decent. As you can see, the flex is already kind of imbalanced. If you look at the numbers from the front driver up to the front passenger up, the numbers change a good bit. The overall flex is pretty close, the total, but it's the front flex is more when you have the front driver up, and the rear flex is more when you have the front passenger up. That's just due to the asymmetry in the KDSS system. You only have a KDSS link on the driver's side of the vehicle. So this is pretty normal. I've done this kind of testing with my truck, my GX460, dozens of times, and I've had the same behavior just about every time. It has changed a little bit as I've added lift and spring rate and longer travel shocks and stuff, but it's usual to see some unbalance there. So no surprises there. So then I added this 1.5-inch spacer to the fixed side of my KDSS. And the first thing I did was measured it flat. The numbers were very close. And then I measured it at full droop. The only noticeable change here, that's really what we're talking about, is the front passenger tire was able to droop a little bit more. It's really only 0.2 of an inch if you look at these numbers right here. But the reason that is because I made the link on the front passenger side a little longer. So that's something I really expected, right? I'm going to get a little more down travel on the passenger side front because that link is longer. So the sway bar is going to let it actually reach full shock down travel because I'm running Bilstein 5100s, which are about an inch more down travel. So that's great. I got a little more down travel in the front. Woohoo. We expected that. Excellent. That's one of the things this mod's advertised to do. Then we go and we do the front driver's side tire up on the ramp, measure everything out, and you can see the flex numbers if you look from this column to this column, pretty similar all the way down. Slight improvement in the front flex overall. So if you add those two together, we get a 2%, right? So I'm going to say that's very slight. I'm not even going to make this green because it's probably in the noise. Let's go ahead and make it yellow because it's very slight. Okay, and then we did the front passenger tire up on the ramp, and that's where everything falls apart. So when you look at this, we're going to look at that's the front because the rear didn't change much, right? We didn't change anything in the rear. And you're trying to figure out, well, what the heck happened here? We went from 2.55 and about 3 to 1.8 and 1.6. That is a huge loss of travel when you're talking about a truck that only has, I don't know, 7 inches of front travel to begin with. So what happened here? So let me know what you guys think about this explanation, see if it sounds stupid. The fact that the front driver's tire was not able to drop down all the way is kind of confusing. So we'll do that 1 second. So you see right here, before I did the mod, the front driver's tire was able to reach 15.3 inches from the fender, the top of the wheel. After the mod, it only dropped down to 14.6. I have a theory for this, but I need a whiteboard. This one's a little more intuitive. So the front passenger tire used to be able to go up to 9.3 inches from the fender. Now it only goes up to 10.6. So we lost an inch, 1.3 inches of up travel. So why is that? Well, we added a 1.5 inch spacer to that sway bar link. So all things, if everything else stayed the same, we made that sway bar link 1.5 inches farther from the frame, which is actually pushing the tire away from the frame. So it makes sense that the tire wouldn't be able to get as far up after doing that mod. I expected to lose a little bit here, maybe half an inch. I did not expect to lose 1.6 inches. But again, this KDSS has some wonky geometry, so the interaction is kind of, there's a lot of moving parts. So I'm gonna switch over to the whiteboard now, and I'm gonna try to explain what's going on here. Why did the driver's front tire not drop down as far? All right, so I'm trying to explain what's going on here. So this is my shitty whiteboard of science. When the truck is sitting on flat ground, aka not on the flex ramps, this is kind of what it looks like. Here's your frame, here's your sway bar, your fixed link, and your KDSS cylinder. Now I called it a spring here, and that's because when you're sitting on flat ground and you're not moving, the KDSS cylinder can actuate, but it's not free floating because there's an accumulator in the loop. So there's actually a lot of pressure being put down onto the sway bar because that's what an accumulator is, right? It's hydraulic fluid with air pressure above it, and that air acts like a spring. So essentially there is some force pushing down here, so I called it a spring. Now this is all fine and good, but what happens when you go on the ramp and you put your passenger tire up? So passenger tire's up, this link is fixed still, right? That hasn't changed. So that makes the KDSS cylinder come down. Fluid flows into the cylinder, and now your sway bar is tilted like this. That's the whole point of KDSS. But now I'm calling it a cable, right? Why am I calling it a cable from a spring? So let's assume that in this front flex scenario, this KDSS cylinder reaches its full max down travel. At that point, it's acting like a cable, and that's where the problem happens. So if this is acting like a cable, this cannot drop down any farther. Even though your coil spring is trying to push the wheel down farther, it's holding it. All right? So this is what it looks like stock. If you were to add a KDSS spacer over here and make this longer, watch what happens. Your wheel actually goes up. You actually lost some down travel.